Good morning, children. So we are dealing with life cycles in algae, and we have seen haplontic life cycle, diplontic life cycle, as well as diplohaplontic. Now today we are dealing with the fourth type of life cycle in algae. It is haplobiontic. Haplobiontic. Haplobiontic type of life cycle in algae. So in haplobiontic life cycle, as the name indicates, there are two haploid stages. Two distinct haploid stages are there, as well as a single diploid stage is also there. That means it is a triphasic stage. It is a triphasic life cycle. Triphasic means here during the life cycle there are three distinct phases. Now out of these three distinct phases, two phases are haploid. Two phases are haploid. That means there are two distinct haploid phases, or we can say two distinct gametophytic stages. Haploid stages we say gametophytic. So there are two distinct gametophytic stages and only one diploid stage, and that diploid stage is represented by a zygote. Diploid stage is represented by zygote. So what are the peculiarities of haplobiontic life cycle? It is more complicated than all other life cycles already seen because it is triphasic. Triphasic means two phases. In all other life cycles, haplontic, diplontic and diplohaplontic, these are only diphasic, only two phases. But here, haplobiontic life cycle, it is triphasic. Triphasic means there are three distinct phases. Now, out of these three distinct phases, two phases are haploid. That means there are two distinct haploid gametophytic phases, and only a single diploid stage, and that single diploid stage is represented only by zygote. Okay, now let us see in detail. Now we can start from the gametophyte. So the normal gametophyte in this algae, it is a multicellular algae, and this gametophyte that will reproduce sexually by producing gametes. Okay, so we can represent male and female gamete. So one gamete is male and the other is female. So this gametophyte, we can represent its genetic constitution within bracket. For every stage you have to represent the genetic constitution. It is very important. So haploid gametophyte, which is the vegetative thallus, it is multicellular, and when the gametophyte become mature, it reproduces sexually, and the male and female gametes, they undergo fertilization or fusion. Now we have to represent fusion or fertilization. So when the male and female gamete undergo fusion, the product is a diploid zygote. Now this diploid zygote, it is the only diploid stage during this triphasic life cycle, that is haplobiontic type of life cycle. Now this zygote is short-lived and soon it will undergo meiosis. So we can represent meiosis in a box. Meiosis is very important. We can call it as the reduction division. Now why we call this meiosis as reduction division? Because meiosis can reduce the chromosome number from diploid to haploid. Okay. So, by meiosis, the chromosome number reduces to haploid stage. And as a result of meiosis, this zygote will germinate and develop into another haploid gametophyte, but we call it as carposporophyte. 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 And it's very important, its genetic constitution is haploid here. In haplobiontic life cycle, the second gametophytic stage. The second gametophytic stage is known by which name? A carposporophyte, but here the carposporophyte is haploid. Why it is haploid? Because this carposporophyte is developed from the zygote on germination, and during its germination the zygote divided by meiosis. Okay. Now this haploid carposporophyte, it is seen attached to the gametophyte in certain algal groups, and when it becomes mature, it will produce haploid carpospore. So this carposporophyte reproduces by producing haploid carpospore, and this haploid carpospore will develop into the gametophyte again. So, during this life cycle, you can see there are two distinct gametophyte and a single diploid stage. So, since the haploid gametophytic phases occur twice, we call it as haplobiontic type of life cycle. So, haplobiontic type of life cycle is a complicated life cycle. It is triphasic, altogether 3 phases. 2 are haploid gametophytic phases and a single diploid phase. And the 2 haploid gametophytic phase, one normal vegetative gametophyte and the other is we call it by the name carposporophyte, and the diploid stage is represented by zygote. Now this haplobiontic type of life cycle is exhibited by some Rhodophyceae members. Rhodophyceae means red algae. Some Rhodophyceae members which belongs to the order Nemaleones. So Nemaleones, a particular order coming under the class Rhodophyceae, and all the members coming under this particular order. So this particular order is divided into different families and they contain different genus. So all the algae which come under or which are belongs to this particular order, they exhibit what type of life cycle? Haplobiontic type of triphasic life cycle. We can write some examples. Nemaleon. Nemaleon is one example. Then we can also write one more example. Batrachosperma. So Batrachospermum and Nemaleon, we both are red algae or Rhodophyceae members, and they exhibit what type of life cycle? Haplobiontic type of life cycle, and it is a triphasic life cycle. What do you mean by triphasic life cycle? A life cycle with 3 distinct phases. And here how many haploid phases? 2 haploid phases and a single diploid phase, and single diploid phase is represented by zygote. Okay, so that is all about this life cycle, haplobiontic life cycle. Now the last life cycle, the last type of life cycle, it is known as diplobiontic life cycle. The last one, the 5th type of life cycle, it is known as diplobiontic life cycle. diplobiontic life cycle. Okay. Now this is also another triphasic life cycle. A triphasic life cycle. What do you mean by triphasic life cycle? It consists of 3 phases. Then stop.